When I was in elementary school, my plan was to become a neurosurgeon. I had no real idea what a neurosurgeon did, and I certainly had no clue of the potential danger of an ill-timed hiccup or sneeze in this line of work, but it sounded so cool. That is what smart people do, I thought to myself, and I knew I was smart. That is, until sixth grade, when it all came crashing down. In sixth grade, it was decided that since I was in advanced reading classes, I should have the same opportunities for math. So I was placed into accelerated math, like regular math, but faster, I guess. This was also the point at which math became much more abstract. There were letters where there used to be numbers and formulas to memorize and far too many word problems about trains. You know the ones. If two trains depart their stations at the same time and one is traveling at 120 miles per hour going east and the other is traveling at 115 miles per hour going west, what color was the conductor's uniform? I was able to memorize formulas and plug them into the problems that were set up in exactly the same way as the sample problem. But as soon as the order was changed or I had to apply it to a context I didn't understand, like trains, I hit a wall. And more importantly, I had no clue why those formulas worked or what they meant. I plugged along in this manner, stressed out and building up a strong identity that I was not a math person over the next several years. I gave up on my dream of being a brain surgeon because clearly I would need to know too much math, and clearly I wasn't as smart as I had previously thought. So I eventually decided to become a teacher, and I'm so glad I did. I was lucky enough to work at a school where we got a lot of training on how to teach reading and writing. I read and learned, and year after year saw my kids grow as readers and writers. But sadly, I brought the same anxiety I had around math to my teaching. While I prioritized sacred time in my class for readers and writers workshops, I would often catch myself saying things like, oops, we ran out of time for math today, until I was introduced to CGI. 2 hours into my first CGI math training, I found myself thinking, oh my gosh, I could have been a neurosurgeon. This way of thinking, teaching, and especially learning just made sense. For the first time, I saw an open-ended way to teach math that met students at their level and built on it. Everything that I loved and had been successful with in the teaching of reading and writing now seemed possible with math. I was hooked. I bought all the books, tried out everything I learned in that PD, and implemented everything I read about. It was a huge improvement over how I had taught math in the past, but it was so much harder than it looked. As my friend Jan would say, I felt a bit like I was conducting random acts of teaching. I could see the learning begin to take hold. I knew my students understood the math at a much deeper level, but I wasn't sure how to plan cohesively and how to balance it all in the most effective way for my students. Then the opportunity to be a COTSIM fellow appeared. As a fellow, I was now able to attend much more PD than I would ever have been able to. And I had the support of my incredible mentor, Clara Galindo, to help me guide my focus and reflect my students' growth and my own along the way. I attended a series of professional development sessions with the amazing Joan Case and decided to venture out and try things on my own. Try things on my own meant that I copied the exact fraction problems that Joan had given us and just changed the names to those of my students instead of the students with whom she worked. Somehow it didn't go as well as it did with the kids in her video. Some kids just stared at me like I was crazy. Maestro Montoya, this problem is wrong. You absolutely cannot share 4 brownies equally with 3 people. Others tried their best to make it work. Each of the 3 people gets 1 brownie and there's 1 left over for you. This one didn't seem like a bad idea. I do love brownies. Others were bursting with confidence, showing me their work after spending 1.2 seconds on the problem. Yes, you're correct, honey. 4 plus 3 does equal 7. Can you show me how that connects to the problem? Another student created a whole variety of number bonds for every equation that used a 4 and a 3 because that's what my second grade teacher told me to do. I knew it wouldn't be an overnight shift, and Clara reminded me that this was my 3rd grader's very first experience with CGI, so we forged ahead. I knew from my experience with workshop that handing off independence to students is the most empowering and important thing we can do for them. But it is messy along the way, and it definitely doesn't happen overnight. And when students haven't had the opportunity to develop that independence yet, it can be frustrating for them and for us. So I supported, encouraged, cheered them from the sidelines, reflected on their work, and planned for the next day. And we began to grow. I got more books and attended more workshops and reflected more with Clara. We noticed that some of my students were correcting each other in a way that didn't feel supportive or productive. No, 6 times 3 is not 19. So I taught them to ask each other questions when they came across some thinking that they didn't agree with or weren't clear on. We practiced revising our thinking and recognized and honored how smart that made us. And we continued to grow. When kids just wrote a total on their paper after spending 30 minutes of doing the most amazing mathematical work counting collections, we looked at mentor examples of how other students represented their thinking and made goals for our own growth. And we continued to grow. I looked at their responses and tried to figure out why so many students were direct modeling numbers that I didn't think they needed to directly model. And then I realized that in almost every math share, I had shared an example that showed direct modeling. So I revised my thinking and stepped out of their way, and we continued to grow. And I questioned them and questioned them and questioned them. I will never forget the time when I asked Emmett how he knew the answer to his math equation using the standard algorithm for multi-digit multiplication was correct. And he explained to me how he'd carried a 1 and lined everything up. I pressed further. Well, how do you know it's correct? He responded, because this is the way you multiply 2-digit numbers. But how do you know it's correct? I asked again, to which he responded, well, because my dad is a math teacher. That day's debrief with my mentor involved a lot of, but I am a math teacher too, kind of talk. But as always, she reflected back to me the power of questioning and that not just any questions will do. I realized that it would have been better for me to ask something along the lines of, can you explain to me what this number means? Or what does this part represent from the story? Or even, is there another strategy you could use to double check your answer? And we continued to grow. And then the pandemic happened and we shifted. And now my PD was not as much about math, but more importantly about how to engage kids and how to look at teaching through a trauma-informed lens. We figured out how to stay connected and we checked in with each other to make sure we were all doing okay. And the Coatson Foundation made me feel important, loved, seen, supported, and most importantly, understood. Christy Maz helped us find systems to collaborate. Arlene Casimir gave us strategies to care for ourselves and recognize when our students needed that care as well. We cried and we grieved and we problem solved and we laughed to keep ourselves sane and we grew closer. As our connection improved and we figured out systems and structures to support one another, we slowly got back to academics. We learned how to do math online, how to provide kids with ways to show and share their thinking. And we found tech tools to help me see the kids' work in the moment rather than just a finished product. Dr. Trill showed us how to use all kinds of fun tools, and the Coatson Technology Grant provided me with the devices to use them. And we grew in a different way, but we still grew. We figured out how to count collections at home. Ben counted Legos, Sebastian counted the slats in his blinds, and Melanie counted her Frozen toys. She has a lot of Frozen toys. Kids struggled to explain their process for counting, so we brought in Flipgrid so they could record their explanations, and my aspiring YouTubers grew. I noticed parents were working so hard to help their kids with their math, but that this help didn't always end up building the kind of independence I had hoped for. Oh, wow, you solved your problem using long division and you're only in 3rd grade. Can you explain how you did that? So I wrote a parent grant and with the help of Coatson was able to lead a 3-session workshop for my families on the hows and whys of CGI math and the importance of letting their kids take the lead. And then not only did we grow, but I began to hear stories of how my students' families tried strategies even with their younger kids. And then more of us grew. The thing about this process that I'm most grateful for has been the chance to grow into the type of educator who is equipped with the strategies, resources, and support I need to inspire my future neurosurgeons to know that they can be neurosurgeons if they want to, or they can be teachers, or any of the other amazing things my students dream of. On behalf of all my students, past, present, and especially future, thank you to the COSIM Foundation, the staff developers, my Phelan fellows, my principal, my amazing husband and kids who understand that if there's a chance for a COSIM PD, I'm going to take it. And most of all, my reflective partner, mentor, and most importantly, my friend Clara, for this amazing journey. Thank you.